We are going to look at identities in this section. So we're going to do a little bit of a review at the beginning. So it says use the given values to evaluate, if possible, all 6 trig functions. So let's look at what they've given us. Sine u equals -3 over 2, or secant, sorry. So secant, if you look at your formula, is r over x. So it says equals -3 over 2. Well, r is always positive. So that tells me that x has to be the -2. Okay, then let's look at tan. Tan u is greater than 0. Well, we know tan is y over x, greater than 0. Well, I already know x is negative. So the only way for that to be true for y is for y to be negative also. So y equals negative something. I just don't know what it is yet. Okay, so let's look at what quadrant is it negative, negative. And that is in quadrant 3. So -2, negative something, and then our r is 3. So we use Pythagorean theorem to find x, or the other side. So -2 squared plus b squared equals 3 squared. So it'd be like b equals 9 minus 4 is 5, so square root of 5. So that's what goes here, but it's a negative square root of 5 is our y value. So I'm going to put that on the triangle. Okay, so now that I have that, I can write all my 6 trig ratios. So sine u equals negative square root of 5. Oops. Negative square root of 5 over 3. Cosine u equals -2 over 3. And tangent u equals negative square root of 5 over -2, which gives us positive square root of 5 over 2. Okay, let's go to the other ones. Cosecant, -3 over square root of 5, which we have to rationalize. So here's our rationalized form. Secant, -3 over 2. Cotan, 2 over square root of 5, which is 2 square roots of 5 over 5. Okay, let's go to number 2. Cotan phi, so this is the Greek letter phi, so it's pronounced F-E-E basically, but it's spelled P-H-I. Okay, so it says cotan is -5. It'd have to be over 1. There's nothing else that would make it -5. So we have to go ahead and assume there's that 1. It's kind of like your understood 1. And so let's look at what cotan is. Cotan is x over y. Okay, and then sine is y over r. Okay, so the y value is going to be positive because this is always positive. So in order for the whole thing to be positive, this one has to be positive as well. So that leaves us with x is at -5 and y is at +1. So -5, 1 is the coordinate that we are going to graph. So -5, 1 will be here in quadrant 2. Ooh, that was a little rough right there. There we go. So then we do a Pythagorean theorem. So b square root of 26 is c. So that's our value. All right, which that makes sense if you look at this because they rationalized. All right, so we already have sine, but let's go ahead and just prove it. So that would be 1 over square root of 26. You rationalize and you get square root of 26 over 26. Cosine negative 5 over square root of 26. So negative 5 square root of 26 over 26. Tan 1 over 5, negative. Cosecant is just square. I go back to my original 1 over 26, square root of 26, and says square root of 26. Secant is square root of 26 over 5. Don't forget your negative. And then cotan is negative 5 over 1, or just negative 5, which we already knew that from here. Okay, I'm going to leave you to do this one. So this is on your own. Okay, so let's look at how to simplify trig expressions. So you do need out your formula chart. So I'm going to show you all that real quick. So this is our formula chart. So we are going to be looking at these identities right here. So make sure you have that out, and let's see what we can do. Okay, so because it says the word simplify, we are just going to use our identities and just make it into simpler, non-complicated form. There is no equal sign, so we are going to use our identities. So I'm going to write a little note. Look at identities. All right, so let's look at number 1. It says sine x cosine squared x minus sine x. All right, something that my algebra brain sees like automatically is that they both have sine x. So that tells me I need to factor. So I'm going to go sine x cosine squared x minus 1. Okay, sine x, we're not going to do anything more there. Let's look at this. Cosine squared x minus 1. So let's look at our formula chart. Cosine squared. All right, so it is this Pythagorean identity. Sine squared u plus cosine squared u equals 1. So if we rearrange that, that's going to be something that we can use. So I'm going to write that down. Sine squared x plus cosine squared x equals 1. Okay, and I want cosine squared x minus 1. So I'm going to subtract 1 and move sine squared x to the other side. All right, so now I have cosine squared x, and then I get this too. So those cancel, those cancel. I get this. Okay. So that's going to be something I can use because see how these are the same? So I'm going to input this. So I have sine x times negative sine squared x. Okay, go ahead and put the 1 out front. If I have like x, let's just think about this as x times x squared, I get x cubed. So the function is what is being cubed, not the x at the end. I guess I shouldn't have used a variable like that, but you get the idea. 3x. And so know that this is not on x, it's on the function of sine. Okay, so this is my simplified form. All right, let's look at the next one. Cosine squared minus cosecant x minus cosecant x. So it's very similar. What does your brain want to do? Look at those that are the same. So we're going to factor it out. Okay, so this is similar to the last one, right? So I'm going to go cosecant x, and then this is negative sine squared x. All right, so look at cosecant on our identities. Cosecant is found by doing 1 over sine x. And then this is squared, so that means it is, let's factor this out front, negative 1. This is times sine x times sine x. So then I can simplify these out, and I just get negative sine x. let's look at the next page. All right, sine t plus cotan cosine t. All right, so I like the original one, sine, cosine, and tan. So whenever I get to like something like cotan, I'm going to look at my identities and see what is cotan. Cotan is, let's see, is either 1 over tan or cosine over sine. Those are the options. Okay, well, I kind of want to get it in cosine and sine, right? Because those are my others. So I'm going to do sine t plus, we're going to use cosine t over sine t times cosine t. Okay, so in order to, let's do it like that. In order to combine like terms, I need to have the same denominator. So this is like over 1. So I'm going to multiply times sine t, top and bottom, so I can get that common denominator. So this would be sine squared t plus cosine squared t all over sine t. That's a lot better. All right, I feel like I've seen this before, so let's look at our Pythagorean identities. And we have this, sine squared u plus cosine squared u equals 1. So this whole thing equals 1. So 1 over sine t. Okay, that is not as simple as we can go, because if we can get just one trig function, then that would work better. So I know that cosecant is 1 over sine. So if you look over here, 1 over cosecant is sine. So look at that. I guess I should have done the other one, sorry. Cosecant is 1 over sine. That's the one I want to use. All right, so this is just cosecant. All right, pretty cool. So number 4 is on your own. All right, let's look at factoring. All right, let's see what we can factor out. Oh, I see this. So let's factor that out. Okay, let's see if we have this on our formula chart. Tan squared x plus 1. Tan squared x. Oh, it's right here. So 1 plus tan squared u equals secant squared u. So I'm going to be able to write this as secant squared x. Okay, so this is just like if I say a squared times a squared. I add my exponents, so it's a to the 4th. So this is secant to the 4th x is our simplified version. Okay, let's look at number 2. Cosecant x minus 1 over cosecant x minus 1. That's a squared on top, so let's see. If I were to switch that to a 1 plus cotan, that doesn't really do me any good. So what we're going to do instead is think about this as like a squared minus 1. This is the difference of squares. So we can apply this with our trig functions too. And this gives me a plus 1 times a minus 1. So this is going to give me cosecant x plus 1, cosecant x minus 1. And then keep our same denominator. All right, and then we can factor those out. And we get cosecant x plus 1. And there, it's not a squared, so you wouldn't do another trig function there. Because it kind of looks like a Pythagorean identity, but it doesn't have squared. So this is where we would stop. Okay, let's look at number 3. 1 minus 2 sine squared x plus sine 4th x. Okay, so this is, if I rearrange it, this would be like a to the fourth minus 2a squared plus 1. Okay, and whenever we factor this, we get like a squared minus 1 and minus 1. Yeah. So we can do that here. So we would do, but let's switch them around. 1 minus sine squared, 1 minus sine squared. But if we switch it around, it'd really be like 1 minus 2a squared plus a to the fourth, which would be a squared minus 1. Oh no, I need to do it the other way, sorry. 1 minus a squared, 1 minus a squared. So I need to switch it around. So 1 minus sine squared x, 1 minus sine squared x. Okay, so I've seen this before. That's on our Pythagorean identities. So look back at that. It's right here. If I move this sine squared u over to the other side, I get a cosine squared u. So this is cosine squared x, and so is this. We add our exponents, so cosine to the fourth x. Okay. Secant to the fourth x minus tan to the fourth x. So this is another difference of squares. So this would be secant squared x minus tan squared x, and secant squared x plus tan squared x. Okay, let's see if either one of these are on the formula chart. So secant x squared and tan x squared. So it's that second one on Pythagorean identity. So if I subtract tan on both sides, I get 1. So that tells me that I can use the identity of this equaling 1. Secant squared x plus tan squared x, which is just 1 times that, so it just remains the same. All right, let's go to number 5. Cosecant squared x minus cotan x minus 3. All right, let's look at our Pythagorean identities. Okay, so we're looking for cosecant. Oh, it's right here. 1 plus cotan squared x is cosecant. So I'm going to replace that with 1 plus cotan x squared. So I'm replacing that. So I'm just going to carry down the rest. And then the only terms I can combine are these. So I have cotan x squared minus cotan x minus 2. All right, so let's think about this as a squared minus a minus 2. So what multiplies to get negative 2 and adds to get negative 1? Well, it's this. So I'm going to do cotan x minus 2, cotan x plus 1. And I don't think there's anything else I can do with that because they're both originals and they're not like the squared, so that means they're not in the Pythagorean identities. So we're done there. Okay, number 6 you're going to do on your own. And number 7, I'm just going to help you out a little bit. All right, sine cubed x secant cubed x minus secant squared x minus secant squared, or secant x plus 1. See how all these are kind of similar? So what we're going to do is we're going to factor by grouping. So these both have a secant squared x. So I'm going to factor that out and put secant x minus 1. And then this would just have a minus 1. So it'd leave me with secant x minus 1. So then finish this out, okay? So I need you to, on your own, finish.